Hey you guys, this is Mr. Sal. This is a lesson on matrices and elementary row operations. So we're going to be specifically using matrices to solve these systems of equations instead of what we're used to with elimination, substitution, and sometimes graphing. So thanks again for watching. Don't forget to like, comment, and subscribe. I don't know, this may sound more complicated than it needs to be, but I tried to condense it into smaller words. Well, less nerdy words, I should say, right? A matrix is just an array of numbers, but we're gonna take them specifically from place. We're not just putting stuff in randomly, unless you guys just wanted to do that, but it makes our answers look really weird. Each equation should be in the same form, so we're looking mostly at standard form stuff. Ax plus by equals c. Or if it's three variables, ax plus by plus cz equals d, maybe. We'll see some three variable stuff, right? So the variables will be in the same order for all the equations. It's important to have the variables in columns. And columns are important for matrices because we're looking at them in rows and columns. Now don't forget though that the answers are still ordered pairs, or if it's three variables, ordered triples. Well, that brings us to elementary row operations, even though there's not really much elementary about them. Okay? Three things that you can do with matrices, and pretty much only three things for now. And that's the first one, is you can switch the order of the rows. So if you want the first row to be the third row, do it, and feel good about it, okay? If you want to take the second row and make it the first one, that's fine as well. You just got to change them. They're interchangeable, okay? So you're removing one, and then you got to replace it, and then stick it somewhere else. All numbers in a row can be multiplied or divided by a non-zero number. This is very similar to what we did with elimination anyways, when we were looking to multiply the equation so that we could get the coefficients to be opposites, which is essentially what we'll be doing with number 2. Okay? And then finally, number 3, the numbers in a row can be added or subtracted to any other row. So you guys remember that after we got the coefficients to be opposites, we added the rows. But you can, well, we don't usually subtract the rows because it changes signs and it jacks up a lot of stuff. These numbers replace the row that has been operated on. Yeah, so when we're operating on a row, it just changes those values, just like it did when we were multiplying or distributing a value to change the coefficients to opposites. So a matrix really, it's an array of numbers, but like I said, they're not random. They usually come from the three equations that we look at, and we're looking at coefficients only. Okay, because as you can see right there, and we talked about that on the last slide, is the x's are in kind of a column right there, the y's are in their own column, and the z's are with the answers, okay? And some people like augmented matrices to look like this, with a little line between those. I don't really use that line. I'm not saying you won't see it though, okay? But you see how we've just taken those coefficients and moved them into this matrix right here without the variables. And in addition to that, it'll be important to notice that the coefficient of this z there in red is 1. But it's a phantom 1, which we will need to show in the matrix as a 1. Otherwise, we can mistake that and put a 0 there, which is a common mistake that I don't want you guys to make. Now, at some point, it may be helpful to look at these outside of the matrix. Okay, is that the blue or the red pill? That's the blue one. Okay, so I don't remember. In any case, you got to look at this outside the matrix, which would just be changing it back into an equation. All right. So, for example, let's just. Well, I guess we can show it on the next one actually. So hold on to that. Okay, now hold on. There's a point to this, okay? So on this bottom one first, this Gauss-Jordan elimination stuff, you can look it up. It sounds fancy. Well, it kind of looks fancy too, so we're good. But let's say that this was a 5 right here, okay? This would come out of the matrix as x equals 5, right? Because there is no y, there is no z, there's just one of these x's right here. Does that make sense how that kind of skipped the x and y's because of the zero stuff? Which essentially gives us our answer, right? That first row gave us x equals 5. The next one would be y equals some value, and then the final row, z equals some value. If we can get it into this reduced row echelon form, I don't know why they call it that. It sounds French, but I don't know French. We don't necessarily need reduced row echelon form to solve the system. If we can get it into just row echelon form, which is this one above it, see, this would give us the z value, which would then, we could take into that second row and then solve for the y. And after we have the z and y, then we can put in that first row for the x. We can switch the rows. So if for some reason your matrix looks like this, well, all you would do to change this into reduced row echelon form formally is to just switch the second row with the third row, okay? All right, so I'm keeping the operations up there just so we can see them and forget about them later because no one ever remembers this stuff. But this one's it's pretty well set up for us. Okay, now this is a system in 2 variables. So it says to change this into reduced row echelon form. So it should be set up like this with the ones and zeros. And then we'll have a number here, which we already have, right, for that first row. We can see it's 40. Right, that first row set up for us just to get us started, right, get a little taste for it, some flavor, and then we'll move on to the other stuff, okay? And well, we don't know what that other number is yet, okay? All right then. Well, since the first row is set up just exactly like we want it, then I'm going to operate on row 2, which is the second row. I count from up to down, so if you do it down to up, it's fine. It just may be a little confusing the way that I'm setting these up, okay? And I'm just going to add to row 2, but I'm going to add to row 2 something from row 1. So I've got to do something with row 1 and put it into row 2 so that I can get a 0 in that bottom left corner, right? Right there. Well, as it turns out, to get that to be a 0, the negative 1, I would just take the 1 and add it to the negative 1 from row 1. I'm going to take the 1 in the x column from row 1 and add it to the x column in row 2 so that the negative 1 will cancel away. All right, so let me just show the operations on this, right? Okay, so this was row 2 as it was, right? Now I'm taking row 1 from the columns and adding those to the second row. So what is the first column in row 1? 1. And I'm going to add that to negative 1. Now I'm in the second column, which was 0, and I'm going to add that to the 1. Then I'm going to go to the third column, and in the first row it was 40, and I'm going to add that to the 25. All right, so what that is, what we've just done is we've used, all I did is I used the third rule right there, the third operation, elementary row operation, right? I took one row and I added it to another row. That's it, okay? Now that gives us a new matrix, and I have these values now, right? 1 plus negative 1 is 0. That's what we wanted, so we're good there. Then I've got 0 plus 1, which is 1. We wanted that, it just kind of happened to be, in this case, that it was a 1 right away. Okay, it kind of rarely happens. Then I've got 40 plus 25, which is 65. And this here is reduced row echelon form. for two variables. Now again, the nice thing about reduced row echelon form is it solved the system for us. Right, we already know that the ordered pair in this case would be 40, 65. By changing these rows back into equations, we get x is 40 and y is 65. Alright, so we'll set this up as an augmented matrix. Then we'll solve. We'll solve the system. We're going to use matrices, of course. I mean, I would expect on the exam that it would say to use matrices. If I'm wrong, then... Alright, so we do need to change this into a matrix, and it may be helpful to see it as a matrix like this, just to get started, right? Because now I can transform this into an augmented matrix. So the x's are aligned in the column. So I've got a 3 and a 1 as my coefficients of the x's. And as the y's, I've got a 2 and a negative 2. And then, of course, in the answer, and that's why they have the line there, just to separate the answers from the variables, negative 9 and negative 3. But again, I don't really use that line myself. Well, now we need to change this into, well, we'll change it into reduced row echelon form so we can get used to it, okay? And to do that, we'll have to use the elementary row operations. So the first one I'm going to do is switch these two because, and it may be helpful to write this out, just the objective here, right? I want 1, 0, 0, 1, and then I need some numbers here on the right, okay? Now I have a 1 in the left column, it's just in the wrong row. So I'm going to switch the two rows, all right? So you guys saw what I just did there. I almost put negative 9 in the top row. I'm trying to speak and focus at the same time, which is difficult for me. So just double check as you switch them that you've got stuff in the right place. Okay, otherwise it's going to throw your answer way off. And yes, you should check your answers on these as well. So that satisfies the 1 being in that top left corner where we want it. The next thing I should do is, I would say the next best option is to make that bottom left corner a 0. Okay, so that's operating on row 2, right? Because right now I've got a 3. I don't want a 3 there. I want a 0. So how do I make a 3 0? Well, it's nice to have that 1 there because operating on 1 or multiplying by 1 is going to be pretty simple, right? Now, yes, I am doing this to row 2, and I'm going to be adding the 2 together. This is, the R stands for row, right? And I'm going to be operating on it from row 1. Specifically in that first column, we'll take care of the rest as we go, okay? Like I still have to multiply the other columns, right? So, what would I multiply that 1 by?
Oh, we're not adding it, we're multiplying.
So remember, it's kind of like getting opposite coefficients for whatever we're trying to eliminate. Right now I'm trying essentially to eliminate the x in that second equation, right? So what would I do to that first row? If I multiplied it by 3, they'd be the same. But I want them to be opposites, so I'm going to multiply it by negative 3. All right, well, what does that do? It didn't do anything to the first row, so it stays the same. But it does something to the second row, right? So if I took negative 3 times that 1 and then added it to the 3, that would give me the 0 that I want. But I got to look at the other columns as well, though, right? I know that's kind of squished. I run out of space there. But yeah, I'm taking that first row operation by multiplying it by negative 3. Then I'm adding it to row 2 to change row 2, right? Because I have that 1 in the first row where I want it. All right, so this is the change that we get. Negative 3 times 1 plus 3 is 0, which is what we wanted. So objective complete, but we got to look at the rest of it, right? We got negative 3 times negative 2 plus 2 is positive 8. And then over here we've got negative 3 times negative 3 plus negative 9 is 0. Now whenever we see a lot of zeros like this, we should be a little concerned. Well, let me rephrase that, okay? Because in reduced row echelon form we see a lot of zeros. It's more about looking at zeros in the answer column, which is the column farthest to the right, okay? But if we can just change this back into an equation, it should help us to understand what we're looking at, right? This is really 8y equals 0, which, I mean, if it was an equation, you guys could solve really quickly. But since it's in a matrix, we don't know what the heck we're doing, right? Because we're new to it, though, which is okay. Now, if this was an equation, what would you do? You would take that equation and divide both sides by 8 to solve for y. Well, you're going to do the same thing with row 2. You're just going to divide it by 8. I did that stuff in my head, which I don't recommend. Because you guys seen I've made mistakes as well. Okay, do it on a calculator, because it doesn't make mistakes unless you tell it to do it wrong. Okay, so we got 0, 1, 0. That's telling us that y is 0, just like we would have found if we had solved that equation, right? 0 divided by 8 is 0. And yes, you could go back, change that first row into an equation, then solve for x, but that'd be too easy right now, so we're not going to do that. What we're going to do is we're going to operate on row 1 now, but we're going to operate on row 1 from row 2. So we did get the 1 in that bottom middle row column, okay? Now what we want is the 0 in the middle top row middle column, okay? Because that's going to give us what x is. And what would I do to row 2 to get a 0 there in the middle column for row 1? Is it looks like I need to multiply that by 2. Right? If I take row 2, multiply it by 2, and then add it to that negative 2, I will have the 0. Okay? Now it's not common for us to show the work in the matrices, but this should show it pretty good. Right? 0 times 2 plus 1 is 1. 2 times 1 plus negative 2 is 0. That's what we wanted. And then 2 times 0 plus negative 3 is still negative 3. We had that last row, 0, 1, 0. And that's it. That's reduced row echelon form, which gives us the answer. Right? That we already see that y is 0. But now this top row tells us that x is negative 3. So there's my answer as an ordered pair. And yeah, you should go back and check those in the equations, right? Like negative 3 minus 0 equals negative 3. That's true. That's the bottom equation that we started with. And then the top one, 3 times negative 3 is negative 9 plus 2 times 0 is 0. So negative 9 plus 0 is negative 9 was true. So we checked off our answer. And on a test, we can know that our answer is correct. Even though these look the same, they are different. They're going to give us different answers, and we will like it. So it should help us, though, in just setting this stuff up just to start with. Right, the first row, 3, that's a positive 2, negative 4. And then the second row, 1, negative 2, and 4. All right, once again, well, I should have done this. I like to have this on the side just so that we can see what our objective is, right? We want a 1 in the top left corner, 0 in the bottom left, and in that middle column we want 0, 1. So, right now I've got a 3 in that top left corner where there should be a 1. So, but in the second row I have the 1 already in that first row, so first column rather. So I am going to switch those just like we did on the last one. For the most part, people really like that operation because it was so easy, right? Didn't have to add, didn't have to multiply, no division, we feel good. So, now though that I have the 1 exactly where I want it, I should focus on that 0 in the bottom left corner now. So, to do that, same idea as last time. I am operating on row 2, so I should do something to row 2 from row 1 to make that a 1. Now, I'm sorry, 0 instead. Some of you guys may think, well, I'll just multiply by 0. No, you can't multiply rows by 0 because then you just kind of eliminated the row, which you can't do. You shouldn't do that. Sorry. So, I mean, yeah, you said to multiply that first row by 3 and then the second row by -1, which would be fine. I'm just going to put the negative with the first row, though, because it's not really going to matter. Well, let's show our work because, you know, we're still new at this and we need to see that work. That's okay. And then the second row, I've got -3 times row 1, so that was a 1 in that first column. And then I'm adding it to row 2, which was a 3 in that first column. And then the second column, well, I should have given myself more space, but I hope that works out for you guys. All right, and this should give us a new matrix. So we got the 0 right where we wanted it, right? And then we got -3 times -2 plus 2 is 8 again. Then I've got -3 times 4, which is -12, plus -4 is -16. Well, I have that accomplished, so I can circle that in the original. Now that I have that 0 there, it's good to go after the 1 there in the bottom middle in that matrix that we're trying to get, right? But right now I have an 8 there, but I want a 1. So how do I make an 8 and a 1? I mean, you could operate from row 1, but that's going to change your 0 back, okay? To make that a 1, what I would do is just take row 2 and divide it by 8. So 8 divided by 8 is 1. -16 divided by 8 is -2. And of course, we still have that 0 in the front there. So that changes the matrix. That changed row 2. And in row 1, I still have 1, -2, and 4.
Also remember that.
Yeah, just to show this, if it were shown fully as an equation, I would have 0x plus 1y
Times 2 with the
equals -2.
plus the first one.
But I don't really need the 0x there, right? Or the positive. So I can see now that y is -2. All right, next up, now that I have the 1 where I want it there in the bottom of the second row, middle column, is I need to make the 0 in the middle column for the first row. And having the 0, 1 there in the second row makes that very easy to do. Okay, so it kind of cycles. So what I'm going to do to row 1 is I'm going to operate on it from row 2 by adding the 2 together, but I need to change the 1 from that middle column in the second row into the opposite of -2, which is 2. So I would just multiply the 1 by 2. Now when I do that, well, we'll show the work on that. But I'm going to give myself more space. The bottom row did not change, and it will not change, but it's going to affect that first row, right? So just showing the work. So that gives us the new and improved reduced row echelon form. I've already got that second row, right? 0, 1, -2. And now I've got 2 times 0 plus 1, which is 1. That's good. That we didn't want that to change, and having a 0 in that column in the second row ensures that. 2 times 1 plus -2, that's a 0. That's what we wanted, so that's done. And 2 times -2 is -4 plus 4 is 0. So this equation spits out x equals 0. And we have the two values we want. So just, again, as an ordered pair, this would be 0, -2. So, I mean, if you guys had solved this using elimination, you would find you're using actually a lot of the same steps. Just they're shown differently, that's all. Now the nice thing about this is they didn't give us the original system, so I don't know, maybe it gives us a little bit more room to work with. And yeah, there are some big numbers, but only in sight, because if you type it in the calculator, it doesn't matter how big the number is, it will do the work for you, okay? All right, so once again, I'm just going to write this out, the objective here, right? I want to get a 1, and then I'll make these two zeros, and then usually I'll make the one in the second row, middle column, a 1, and then the others in that same column, zeros, and then in the third column, in the third row, a 1, and then the same column for rows 1 and 2, zeros. Of course, that'll produce numbers in that fourth column. Here we go. Oh, this one's nice, actually. They have the 1 there already, so mission accomplished. We got the 1 in the top left, which is where we want it anyways. Now I'm going to use that 1 to make zeros in the first column, in the second and third rows. Okay. Oh, man. All right, so on that second row, right, I got row 2. I'm going to operate it on it from row 1. I'll add the 2 together. But I need to make that -6 a 0 from the 1. So if I can just make that 1 a +6, I just multiply that by 6, and then that will cancel out that -6 in the first column, in the second row, right here. So that first row we didn't touch, which is okay. But that second row, we worked on it, right? So that is going to change the second row. I'm going to leave the third column alone to save space, which sounds weird, but hopefully it'll be helpful as well, okay? Because I don't only want to make that -6 a 0, but I want to make this 2 a 0, which I'm going to do here in a moment. But let's show that that second row gives us a 0 in that first column, okay? But now I have 6 times 1 plus -6, which is 0. And now the second column, right? I didn't have space for that third one. Sorry. But here we go on the second one. Second column, second row. 6 times 3 plus -17, 1. That third column would be 6 times -3 plus 15. So 6 times -3 is -18 plus 15, -3. And then the last column, 6 times 200, 1200 plus 100, 1300. So that's what we wanted on that second row, was to make this a 0. And we've done that. Okay, but we want to do it in the third row, and we can operate on it from the beginning as well. So let's go back. I'm going to be operating on row 3 from row 1. So how do I make that 1 in row 1, column 1? Eliminate the 2 in the third row from column 1. Yeah, you're going to have to multiply row 1 by -2. Right? So showing the work again as much as I can fit. All right, as much work as I could fit into that. Let's go ahead and fill in these values. I got 0. Oh, that's a 0 too. We're going to benefit from that being a 0 right there. And then in the third column, I would have had -2 times that -3, which is 6, plus -5 is 1. -2 times 200 is -400, plus 350 is -50. This is rare for this to happen, but it's convenient that it has. Well, we've got the 0 in that second row, first column, and in the first column of the third row, but it also produced in that third row a 0 in the second column and a 1 in the third column. And in the second row, second column, a 1. That's great. That right there is row echelon form. which would be enough to solve the system. But they wanted this in reduced row echelon form. So we'll continue, even though it's really not too bad, okay? So what I'm going to do is I'm going to use the second row, that one there, to eliminate the 3 right here, okay? Because this is a 0 in that first column, so I can multiply it and add it to the first row, and it's not going to change anything. Just like we did on those last 2 matrices. So what I'm going to do is I'm going to operate on row 1 from row 2. We'll add the 2 together, and I'm going to change this 1 into a negative 3 so that it will cancel. Okay? Yeah,
Isn't that
that'll
gonna
work.
change?
Okay, well, that gives us a new row 1. And, well, I guess we didn't operate on row 2 yet, although we could have, okay? So we'll just keep this as is. And this changes now, so 0 times negative 3 plus the 1 is still 1. And then negative 3 times 1 plus the 3 is 0, which is what we wanted, because that takes care of that 0. And then I've got negative 3 times this negative 3 plus that negative 3. Well, that would give us 9, plus the negative 3 is 6. Then I've got negative 3 times the 1300, which is negative 3900, plus the 200 is going to give us negative 3700. All right, so that sets up pretty well for the next matrix, because now that I have this 1 here in the third column of the third row, I can use it to eliminate the negative 3 and 6 from the third columns of the first and second rows. So to do that, I'm going to look at the second row, and I'm going to be operating on it from the third row. And to make that 1 cancel out the negative 3, I'll have to multiply it by a positive 3. So we can go through the row, right? And we got 3 times 0 plus 0 is still 0. 3 times 0 plus 1 is still 1. So see how that doesn't really affect anything with those zeros, right? But now I've got 3 times 1 plus negative 3, which is 0, and that's what we wanted in our format here. But I've got to do it with negative 50 as well. Times 3 is negative 150, plus the 1300, which would give me 1150. And that right there solves for the y value. Next up, what I need to do is get rid of the 6 in that top row. So from on row 1, I'm going to operate on it from row 3. And to make that 6 become a 0, I'm going to have to, again, operate on that 1 by multiplying it by negative 6 and then adding it to the 6. So I've got negative 6 times row 3 plus row 1. And then we'll just continue with this operation. I've got negative 6 times 0 plus 1 is 1. Negative 6 times 0 plus 0, still 0. But negative 6 times 1 is negative 6 plus 6 is 0. So that accomplishes our objective in the beginning to get 1, 0, 0, 0, 1, 0, 0, 0, 1, which is reduced row echelon form. But I've got to finish that off to find that x value. So I've got negative 6 times negative 50, which would be 300. So 300 plus the negative 3,700 would be negative 3,400. And that's our answer. Of course, we could change this right into the equation. So this is x is negative 3,400. Purple shows that y equals 1,150. I think I missed a 0 for that 3,400, right? There we go. And then finally the z equals negative 50. Now we should check this, which you could do with the 3 equations, but that'll do for us right now just to save some time. yeah, we have that in reduced row echelon form, so that's all we need to do for this problem. All right, so we'll solve this system here. We'll change this into a matrix first. So I have, there's a value that's missing in that second row, right? Let's do the first row first, right? 1, -2, 1 and 2. The third row's fine, 1, 1, 3, and -13. But notice the second row does not have an x, so it's just going to be 0 there, because there is no x. And then the y has a coefficient of 1, z a coefficient of 2, and the answer is -9. Alright, so that's what we should be looking for, right? That's what we want with the ones and zeros. And right now I have a 1 where it should be, and this 0 is where it should be. And I also have this 1 also where it should be. So we won't have to manipulate anything for those values. But we will have to for this 0 in the bottom left, okay? So what I'm going to do to row 3 to make this one a 0 is I'm going to operate it on it from row 1 by taking the opposite of row 1. And then when I combine these, it's going to cancel out that 1 in the third row. And -1 times row 1 plus row 3 is 0. -1 times -2 plus 1 is 3. -1 times 1 is -1 plus 3, 2. And then -1 times 2 is -1 plus -13, -15. Now I'm going to take the 1 in the second row, second column, and use it to manipulate the first and third rows so that I get zeros here and here. Okay, so I want that -2 to be a 0 and the 3 to be a 0 from row 2. So I'm looking at rows 1 and 3 from row 2, and we'll add these. So I'm going to make this -2 a 0 first by multiplying the second row by 2. Alright, so what does that do to the first row? I got a 1, a 0, and then 2 times the 2 plus 1, that's 5. 2 times -9, -18 plus 2, -16. Alright, then from row 2, I'll take the opposite of row 2 and just add, wait, no, what am I looking at? I need a -3 from row 2. Then I'll add that to row 3 to make that 3 here a 0. So I already have the 0 here, which is fine. And then I've got -3 times 1, which is -3 plus 3 is 0. -3 times 2, -6 plus 2 is -4. And then -3 times -9, that's going to give us positive 27 plus the -15 is 12. So now we have this system, and yeah, we got the first two columns taken care of. What we need to do now is to make this one, this -4, this 1 here, okay? So to do that, all I'm going to do is take row 3, and I'm going to divide it by -4. Because -4 divided by -4 is 1. Of course, I'll do 12 divided by -4, which is -3. And we're almost there. We just got to get these two zeros now out of this 2 and 5. But since that third column in the third row is already a 1 right here, it's not going to be too hard, all right? So let's start with row 2 first. And we're going to operate on it from row 3. But I need to change that 1 into a -2 so that it'll cancel out with this 2 here. So I'm just going to multiply it by -2. So what does that do? -2 times 0 plus 0 is 0. -2 times 0 plus 1 is 1. -2 times 1 is -2 plus 2 is 0. -2 times -3 is positive 6 plus 9 is -3. And that's that second row, which is good. Next up, I'll operate on row 1 from row 3 as well. So I'll add these two together. But now I need to change that 5 into a 0 from the 1, right? So I'll just multiply that 1 by negative 5. And now when I multiply that out, it'll get a 0, right? So negative 5 times 1 plus 5 is 0. And of course, these other values aren't affected because they were already zeros and ones. And so we're just looking at the fourth column in the first row. I got negative 5 times negative 3 is 15, plus negative 16 is negative 1. And again, that gives us the solution to our system. I've got x is negative 1. I've got a y that's negative 3. And a z value that's negative 3 as well. So I can plug these in to an ordered triple if it were necessary for us. I got x is negative 1, y is negative 3, and z also is negative 3. And that solves this system of equations.